Okay, so I was saying, I don't remember what you saying. Train of thoughts about that one. Once it gets gone, gets interrupted. That's all right. Okay, everybody did more or less the right stuff here. You know, I remember what I was saying now, and everybody got an answer. And I don't know if the answers agreed or not. I didn't look that closely. But there are a lot of steps in this thing, and there are a lot of opportunities to make errors. Okay, little, you know, you get the sign wrong, this, that. But what I saw was I think everybody's following the right process, and that's good. Okay. So I'm confident that with appropriate amount of practice, everybody will be okay with linear equations of this nature. And that's about as complicated as they get until you put denominators into them. Now with the denominators, nobody's doing what they need to do. Okay, which is multiply by a common denominator, multiply both sides by a common denominator. And maybe one reason is that when I asked, most people are unable to tell me how to find any common denominator, much less the least common denominator. Least common denominator is the least common multiple of your denominators. Okay, I'm gonna write this out very logically. I want you to review it because it's going to be important and it's going to stay important. Okay. I mean, everybody did okay on adding fractions, but you know, I've advised you, it's tough to learn how to learn mathematics. Okay, if you did the homework and a week later you don't have an immediate clue about what you're doing, you're going to recognize when to do it, but you know, then you haven't really learned it. Okay, so make sure you do things in the way you learn. Make sure that when you get at least to the later problems, second half of an assignment, you're not looking at anything when you solve your problems. If you're looking at an example and imitating it, you shouldn't be doing that after you've done the first half. Generally, sometimes the topics skip around a little bit, but the principle is you want to know how to do these problems and come in here and do them on a quiz anytime during the course. Now, yeah, naturally, you're going to lose track of some things. You're going to need a bit of a reminder, okay? But most people need too much of a reminder on least common multiples and least common denominators, okay? So I'm not getting on you, I'm just telling you, adjust how you do these problems, because you do pretty well on the homework if it gets done, okay? But really comes down to how are you doing it? Are you doing it in such a way it's going to stick with you? We'll be working on that idea all semester. Okay. Okay, so what do we have here? Okay, 80 is not the best number, but multiply both sides of this equation by 80. Go ahead and work out the details. Okay. First, and multiply has only one element. I was writing an L and a T and I got carried away. Okay, so we're going to write 80. The way you really write this out is you do this. Okay. Probably don't want to skip this step. 80 times the whole side equals 80 times the whole side. Now, I've already said 80 isn't the best number you could use, but it works. We'll figure out what the best number is in a minute. Okay, so this is the same as 80 times 3/5 x. And since I'm multiplying by a fraction, I'll write 80 as 80 over 1. And the same thing with the 5/2. And on the other side, well, again, we'll do 80 over 1 times 7/8 x plus 80 times 3. There's a tendency to forget that 80 times 3. You're busy multiplying 80 by fractions, and you're doing that right. And then you forget to do 80 times 3. Now, I'm not sure anybody did, but that is a strong temptation. Okay, very easy to leave that off. And if you write it out like this, with the parentheses, you're less likely to do that. No rush. Okay, I mean, I know you get time pressure in your life, but don't rush through problems. Okay, I don't even put time limits in your test. You take all the time you need. I'm not interested in how fast you can do it. I'm interested in whether you can apply the rules. I want to see all steps. Okay, so well, this is, we could write this as 240 over 5x minus 400 over 2 equals 560 over 8x plus 240. There are other ways to do it. You could just divide the 5 into the 80 here and then multiply by 3, right? You could divide the 2 into the 80 and multiply, it doesn't result by 5. You divide the 8 into the 80. That all works. Okay. Anyways, 5 into 240 is 48. 400 divided by 2 is 200. 8 into 560 is 70. Plus 240. Now you don't have any more fractions. Okay. Now the question I want to pose is, where did I get 80 from? How did I know to multiply by 80? Which I said also is not the best number to use, but it's all manageable. Okay. But you want to use the best number if you possibly can. Ooh. I don't know when I'm recording and when I'm not. Okay, well, you heard it in all its gory detail. I don't know how much of this I did. I'm going to go very quickly. Okay. Our denominators are 5, 2, and 8. Here's our equation. Our denominators are 5, 2, and 8. We do prime factorizations. If you don't remember how to do a prime factorization, review it. Okay, it's a simple process. 5 is prime because nothing divides 5 evenly. No integer. No whole number divides 2. But you can divide 8 by 2, which gives you 4, which you can divide by 2, which gives you 2 times 2. So 8 is 2 times 2 times 2. We've common multiples 2 times 2 times 2 times 5. Why? Well, you need 3 2's. You got to have those. And once you got 3 2's, you got this one. And then you just need a 5. And right there it is, it's 40. And well, we multiply both sides of this equation by 40. Multiply this term by 40. Well, I've got 3 dots here indicating a step that I did in detail over here with the common denominator of 80. So you should fill in those. Gives me 24x minus 100 equals 35x plus 120. 3 more dots where we subtract the 35x from both sides and add 100 to both sides. We get negative 11x equals 220, and x then equals negative 20. Okay. We plug that in here. Actually, I think I did that. I'm confusing one problem with another. Okay, but there it is. You saw the steps. Just in case, remember I didn't put a negative in front of my 20 originally and ended up with something that was going to be equal down here. Went back and said, okay, there's my flaw. I didn't put a negative in there. And then I just worked it out step by step by step by step. 3/5 times negative 20 is negative 12. 7/8 times negative 20. Negative 20 over 8 is 5/2. So we get a negative 7/5. 7 times 5 over 2. Then we got the plus 3. Then we multiply both sides by 2. We don't want to work with fractions. We don't have to. Actually, we didn't quite yet. We multiplied the 7 by the 5 to get this. Then we multiply both sides by 2. Got this, which is very simple. And just did the arithmetic. We got negative 29 equals 29. On this problem, everybody pretty much did this. Then some people started adding 10 to both sides, and then another step, adding 7 to both sides, then another step, subtracting 8 from both sides. Too many steps. Okay, that's not wrong, but it's got a higher chance of something going wrong. Something going wrong. You miss a step, you miss a minus sign, one trivial little thing or another. You know what you're doing. I'm confident you could do that. Okay, but if you did it 3 times, one time probably be different than the others because you forget something. Okay, so you're more likely to get it right if you simplify this side to 6x minus 3 and simplify this side to 19x plus 8. Okay, simplify both sides before you start doing stuff. Well, then it's very straightforward. We subtract 19 from both sides. We add 3 to both sides. Get negative 13x equals 11. Fill in the steps yourself. And then there's a step here where you divide both sides by 13. You get x equals negative 11/13. Okay? Then we check it. Now, checking it, we take our solution, plug it in here, here, and here. Then we get this. You don't do anything, we just write it down. At this stage, you see you've got a denominator of 13, you're going to want to multiply by 13. Okay? Because that's going to clear your denominators. But don't do it yet, because multiplying by 13 when you got all those parentheses is going to be very dangerous. Okay? Really easy to miss something. Okay, so let's do the distributive law. We do the distributive law here and here. And we get, well, here are the terms. I'm not going to read them to you. And then we simplify. Well, we multiply the 6 by negative 11 to get negative 66 over 13. Negative 10 and 7 gives us a negative 3. And here we got 20 times 11 is 220. It might be a little hard to read. 220 over 13 negative. And then we got 8 and 11/13. At this stage, we're not going to add the 8 and 11/13. We're not going to do any fraction additions. We don't need to. We never need to if we've got an equation. We multiply both sides by 13. And 13 times this gives us negative 66. Fill in the step, write it out. 13 times this minus 13 times this equals negative 13 times this equals plus 13 times this plus 13 times this. You want to write out that step so you can always check it. Then you have negative 66 and negative 39. 13 times negative 220 over 13 is negative 220. 13 times 8 is 104. 13 times 11/13 is 11. You add up all the numbers here, you get negative 105. You add up all the numbers here, you get negative 105. Checks, so you know you got the right answer. I don't think I saw anybody get negative 11. Did anybody get negative 11/13? A lot of steps in the problem. You're going to mess up something. Figure out what you messed up. Okay? And fix it, because you know how to do everything. What you need to learn to do is do everything carefully enough to get an answer that checks. If you always check your answer, you're going to be motivated to get it right the first time, and you're going to be more careful. Because you go through that whole check, which is itself a pain in some cases, and it doesn't work, okay? And you got to reconcile everything. That's how you learn. You get immediate feedback if you check and it doesn't work. Or if you check and it does work, which I hope it does almost every time, okay? Okay, we got the equation 4ab equals c. We want to solve it for b. So we have 4ab equals c. If we divide both sides by 4a, then 4a divides 4a gives us 1. So this gives us 1b equals c over 4a, or just b equals c over 4a. Right? We check that. We have 4a, and then for b, we substitute c over 4a. Okay. Now, if you like, you can put that 4a over 1. This is the same as 4a over 4a times c over 1. Now, open math will tell you just cross these out. Don't cross them out unless you know their factors. Okay, you know their factors if you can factor them out like this. So this is something you can kind of do in your head if you want to make sure. But anyhow, 4a over 4a is 1. Times c over 1, and that equals 2. So you get c equals c. Now, open math try to tell you just cross this out and cross this out, you're left with c. Okay. Think about why you cross them out so you don't start canceling incorrectly. All right, another questions. xy plus z equals 9. Give you a minute to work on that. I'll be back in 2 seconds. And everything's still recording. Okay. Solving this. X. Thought I said it, but I didn't write it, so I probably didn't say it. Okay. So what's the first thing you're going to do if you want to solve this for X? Okay, now, people want to tell me the first step ought to be divide by 2y. That can actually work, but kind of a general rule is do additions and subtractions before you do multiplications and divisions. It's like your order of operations. Okay. And you see, we're trying to isolate X, that Z is in the way. Okay. We get rid of that Z by subtracting it. Whereas if we divide by 2y, we haven't really isolated X. Okay. And we've done a division first, and that's a little more complicated. You get there that way. It's not a wrong thing as long as you remember to divide everything by the 2y. So what we do is we Okay, so I'm gonna say you want to add or subtract before you multiply or divide. Okay, well, there's nothing left over here with X to add or subtract, so X is multiplied by 2y. You're going to divide by 2y. Go ahead and do that while I'm writing this out. So my statement is, there's nothing left to add or subtract in order to isolate X. All you gotta do is get rid of that 2y, which is multiplied by X, so you divide by 2y. You get 2xy over 2y equals what? And not everybody's gonna see it the way I said it. I say divide by 2y. Now it's implicit, I divide both sides because that's rule for equations. If I divide one side by something, I've got to divide the other side by the same thing. Otherwise, the equation goes out of balance. So what we end up with then is, okay, this side got divided by 2y. 9 minus z has to be divided by 2y. Now, 2xy divided by 2y, the 2 divides the 2, the y divides the y, and I end up with x equals 9 minus z over 2y. Now, I'm not going to go through the check of that. Partly because of space, but partly because this step isn't totally clear to everybody. So I'm going to pose another problem, similar problem. Here's a problem to solve for A. Okay, here's the equation we want to solve for A. Written down the statement, A is multiplied by BC. A is multiplied by BC, that's clear. How do you undo multiplication? You divide, okay? If you take A multiplied by BC and divide by BC, then BC divides BC. It's the same thing divided by itself, it gives you 1, and that leaves you A. So we get A, B, C divided by BC equals D plus EF divided by BC. Now there's an intermediate step here that you want to understand. This A BC over BC could be written just A times BC over BC. That would be like A over 1 times BC over BC. BC over BC is 1. So this is 1, A is over 1. That leaves you A. And here we have the solutions. It's a one-step solution. Now that's a whole lot like this one, where we're dividing 4AB by 4A in order to isolate B. The right-hand side was a little more complicated, but there it was. Okay, now let's try this next. Let's just take that one. XY plus Y equals YZ. Okay. Okay, solve this for X. First thing we got to do is subtract Y from both sides. If I subtract first, that's just part of the idea of you subtract or add before you multiply or divide. Now you want to write it this way, that's okay. I prefer it linear because it kind of leads to fewer mistakes. Okay, XY equals YZ minus Y. There's a tendency to treat this as a division. It's not a division. This is an addition. So it's YZ plus negative Y. Yeah, got a question. Okay, now one person clarified that they didn't divide by Y, they just subtracted this Y from this one. You can't subtract this Y from this one. This Y, put up with that Z, maybe Z is 12. If you subtract Y from 12Y, do you get 12? No. Okay. That makes sense. You want to check that all out. Okay, now, we're out of time. But the last step. Now divide, when I'm saying divide, we're dividing both sides by Y. So we have to write out XY over Y equals YZ minus Y, the whole thing over Y. Okay. And this gets a little more complicated. XY over Y does give us X, Y divided by Y. Which Y are we going to divide by this Y? Well, we've got to divide them both. It's a distributive law. So I'm going to write it this way. Okay. Y divides everything up. Divides this one, divides this one. YZ over Y, the Y's divide out, give you Z. Y over Y is 1. A very simple solution. Okay, now, gonna have to spend some time on this probably. Open Math will explain it. I think I've got a good set of problems there with videos and exercises and so forth. But that's your only assignment for Thursday. Over the weekend, you'll have a couple more that are probably easier. This solving formulas is usually a big stumbling block. Okay, so spend some time on it and try not to stumble.